The Stirling engine is recognized by the Department of Energy as a promising alternative to the internal combustion engine. An external combustion engine, the Stirling burns any fuel, creating heat for the cylinder. The heat itself powers the engine. Any fuel can be used, liquid, solid, or gas. The Stirling even operates on heat from nuclear and solar energy. Combustion is continuous and complete, quiet and clean. Ongoing research in aeronautical and automotive engines at the NASA Lewis Research Center in Cleveland, Ohio, indicates the Stirling may be the engine of the future. Feasibility studies by manufacturers indicate the technology to produce Stirling engines commercially exists today. Value engineering studies have shown the Stirling can be manufactured in low production volumes at a competitive cost. The engine can be built to provide power for both propulsion and stationary applications. A Stirling engine developed by Mechanical Technology Incorporated for NASA Lewis Research Center and the Department of Energy has been evaluated by a NASA Technology Utilization Program under actual driving conditions. The Stirling engine was installed in an Air Force van. The van's original 150 horsepower diesel engine was replaced by a 75 horsepower Stirling and assigned actual duty service at Langley Air Force Base in Virginia. Air Force operators drove the van throughout the test, serving 10 to 15 aircraft on a flight line, driving from base to aircraft, moving about the field in and around aircraft, stop and go, hauling personnel and equipment. Performance was monitored by special equipment mounted in the van. Engine speed, vehicle speed, and miles accumulated were recorded daily. During this Air Force mission, 3 different fuels were used: unleaded gasoline, JP4 aircraft fuel, and diesel fuel. The van functioned normally during the 1-year evaluation period on whatever fuel was available. The Stirling's high torque capability at low speeds enabled towing of all heavy support equipment. After 1,400 hours and 7,000 miles, results showed improved fuel economy. A second vehicle, a standard Air Force truck, was also evaluated. The truck's original 95 horsepower internal combustion engine was replaced by a 75 horsepower Stirling engine. Tests were conducted over a 1-year period for 1,000 hours and 19,000 miles of open highway and city streets, on rough and rural roads, and in normal traffic in a variety of environments. In moderate climate, the Norfolk, Virginia area, an expediter mission at Langley Air Force Base. Hot, moist sea air environment, a general transportation assignment at Eglin Air Force Base, Florida. Hot, dry environment, base taxi service at Randolph Air Force Base, Texas. In the north, a base supply mission at Offutt Air Force Base, Nebraska. In addition, the truck was driven from Texas to Washington, D.C., a distance of 1,600 miles. The entire trip averaged over 50 miles per hour. The Stirling consistently delivered more miles per gallon. Current engines are a major contributor to the severe atmospheric pollution in our cities today. Exhaust emissions were evaluated, and the Stirling engine met federal emission standards. No catalytic converter or particulate trap was needed. The exhaust is cool and clean. The Stirling engine can help reduce these pollutants to meet even the most stringent California standards. Also, several maintenance requirements were eliminated, with only 1 spark plug to start combustion, no carburetor, no catalytic converter, and no muffler. Because the engine oil is not exposed to combustion products, it stayed clean and uncontaminated throughout the test, eliminating the oil changes. The Stirling engine offers increased fuel economy, multi-fuel flexibility, and reduced life cycle costs. Its economy and efficiency of operation are being demonstrated. The Stirling engine appears ready for market. NASA's Technical Utilization Division continues to work with U.S. industry, providing data to manufacturers and end users, answering the questions on Stirling technology. And the technology is available now to build the power plant of the future today. Power for America, on the land and in space. The Stirling engine, an alternative power plant of the future.